Okay, so now you can have so right now we begin the another topic. Everyone is okay?
Yes, sir.
Hello?
Yes, sir.
Okay.
Yes, sir.
Okay, so now sequences and series. Okay, so uh, let us have first the sequence. So like you are having, say like if I write 1, 1 by 2, 1 by 3, this is a sequence and so on. This is a sequence. In short, we can write in this way 1 by n. Okay. Same way, this is also a sequence. Say 1, then -2, then 3, say -4, then 5, say -6. This is also a sequence. Okay. You can write these sequences also in this way, like -1 power say n minus 1 into n. So if it is 1, then 1. If it is 2, then it is -2. If n is 3, then it is 3. Okay, like that. So that is sequence. So we ask natural question that this is a sequence. So if we can find out, so in general it is written in this way, an, like this, a1, a2, a3, and so on. These are the terms of the sequence. Like a1 is say 1, a2 is say 1 by 2, a3 is say 1 by 3, and so on. Okay. If we can find the limit n tends to infinity and this sequence an, and if we can find the limit, say suppose L, then we can say that sequence an is convergent. Then we can say that sequence an is convergent. Like say limit n tends to infinity 1 upon n, we know it is 0. So you can say that sequence 1 upon n is convergent. So if limit exists, then the sequence is convergent. If limit does not exist, then the sequence is not convergent. Not convergent, there is another name like this. If limit n tends to infinity an does not exist, sometimes it is infinity, sometimes it is oscillating sequence, so limit does not exist, then you can say that sequence an is divergent. Okay, like this is divergent sequence. This limit does not exist. This limit does not exist. ચાલ્યા કરે જો તમે 1 -2 3 -4 5 જ્યારે આમાં શું થાય 1 1 by 2 1 by 3 1. You can see that after certain stage slowly it goes towards 0. But here in 1 -2 3 -4 it does not go, means towards any number. Okay, so this sequence does not exist, and therefore you can say that this sequence divergent. Okay, so this is about the sequence, and next is nothing but the series. Mainly we are going to study the series, but before that we need to at least know what is sequence. Okay. So the next is nothing but the series. So this is infinite series. Now you know about the sequence. Okay. So series, infinite series is what? So infinite series is nothing but, say, if you are having a sequence an, so then if you take the sum like this, a1 plus a2 plus a3, these are the terms of the sequence. If you take the addition of these terms, infinitely many terms, okay, infinitely many terms, and so we write in this way also, that series n equal to 1 to infinity an. So this is infinite series. There are infinitely many terms, and we are adding all the terms. That is called infinite series. Okay. Now the thing is, uh, the question we ask is, there are infinitely many terms, and we are adding all the terms. That does the sum of this infinite series possible? That is the question. Okay, because we are having infinitely many terms. So if you go on adding one by one term, naturally it is not possible, because there are infinitely many terms. But there are some methods by which we can find out the sum of the infinite series. The question is, what is sum? There are two things now. Does the sum of infinite series possible? Like અત્યારે આપણે આવો જ ક્વેશ્ચન પૂછે છે કે સમ પોસિબલ છે કે નહીં. ઓકે, એવો ક્વેશ્ચન નથી પૂછતા what is sum. Okay, there are two things. If you give these two answers, even if you give only this answer, that sum is possible, but what is the sum, it's difficult to find in sometimes in some of the series. So if answer is yes, then you can say that that series is convergent. Okay, if the sum is possible, we are not saying right now what is the sum. So sometimes we can find out exact sum. So there are two questions. One is, does the sum possible? If the answer is yes, that series is known as convergent series. Okay, and sometimes we can find out even its exact sum also. That is very okay, because you are having infinitely many terms of the series. There are infinitely many terms. Then also sometimes we can find out exact sum. But even if you answer this question, sum is possible, then we can at least find out very approximate, very near to the exact sum, because we can use then computer. So that is called infinite. And if the sum is not possible, we call divergence. The sum is not possible, we call the divergence series. Now, there is one definition to check the convergence of the series. So, uh, let us see what is that one. So, you are having infinite series like this. Now we find the, so you are having what? A1 plus A2 plus A3, A4, and so on. Continue, go on infinitely. Okay. Is that okay, everyone?
Yes, sir.
Hello? Okay. Now we write S1. S stands for the sum. Let's say A1 only. Only one term we take, we write S1. S2, A1 plus A2, sum of the two terms, first two terms. S3, three terms, and then take the sum. And so on, Sn. Take the sum of the first n terms of the series. So now you are having one sequence like S1, S2, S3, S4, and so on, Sn. That is a sequence. In general, you can say this is sequence, and this is called sequence of partial sums. Sequence of partial sums. Now, if limit of this sequence is, say, suppose L. Limit of this sequence is, say, suppose L. Then series n equal to 1 to infinity an, that means infinite series, the sum of this series is also L. That means convergent. Convergent ने CGT लगी. Farithi. You are having infinitely many terms of the series. Then you find the sequence of partial sums. Always not easy. Okay, this is definition. Always not easy to find out Sn. But in one or two example we will take, but always not easy. And then you are having a sequence of partial sums. If that sequence is having limit L, then you can say that the underlying infinite series is also having some L, exact sum L, and so the series is convergent. Okay, this is the definition of the convergent of infinite series. Definition. Okay, if you want, you can write. But written.
Yes, sir.
Okay. Fine. So then we take one example. Let us see. The question is like this. Test. The convergence of the series like this. 1 over 1 into 2 plus 1 over 2 into 3 plus 1 over 3 into 4 and so on infinitely many times. We need to check whether this series is convergent or divergent. Okay. Let us see how we do. So this is series AN. Okay. Basic thing is we need to find out Sn. Right now we are using this definition root. Sn is what? A1 plus A2 plus and so on An. That is Sn. Okay. Fine. But so what is An here? Nth term of this series is what? 1, 1, 2, 3. So this is N, 2, 3, 4. So it is N plus 1. Agree?
Yes, sir.
Okay. Can I write this as 1 over N minus 1 over N plus 1?
Yes, sir.
Okay. Now, if you can write in this way, then we are in a position to write down Sn easily. Okay, we are in a position to write down Sn very easily. So, Sn is what? A1 plus A2 and so on. Okay.
Yes, sir.
Okay. So, A1 plus A2, say plus A3 and so on An. That is nothing but the Sn. Now, what is A1? In this fashion, I want to write. So, can I write A1 is 1 minus 1 by 2?
Yes, sir.
Okay. What is A2?
1/2 minus 1/3.
1 by 2 minus 1 by 3. Okay. Same way A3 1 by 3 minus 1 by 4. And so on. What is An? 1 by N minus 1 upon N plus 1. Can I write this as 1 minus 1 upon N plus 1?
Yes, sir.
We can write. Okay, because this cancel, this cancel here, and this cancel the previous with the previous term. What it remains is this one, and this is 1 upon N plus. So this in this example, this will be easy to find out Sn. In every example, this is not easy to find out Sn. Now, what is the definition? If limit n tends to infinity, Sn equal to L. So now we find the limit n tends to infinity Sn. So that is equal to limit n tends to infinity 1 minus 1 upon n plus 1. What is this limit?
1. 1.
1. Because limit n tends to infinity 1 upon n plus 1 is 0. So this limit is 1. So if this limit is L, that means here L is 1. So what does it mean? Series n equal to 1 to infinity An, or you can say series n equal to 1 to infinity 1 upon n plus 1 equal to 1, and so it is convergent. તો તમે જો આ જે સિરીઝ આપેલી છે આખી infinitely many terms, એ બધાનો એક્ઝેક્ટ સમ કેટલો થશે? 1 થશે. So in this example, not only we find the exact sum is possible, but we actually find the exact sum also. Understand?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So write down this. Written?
No, sir. 1 minute.
Okay.
Done, sir.
Okay. Fine.
Yes, sir.
Yeah. Let us now see one more example. Like this. Test the convergence of the series sigma n equal to 1 to infinity. This is infinitely, okay, and 1 upon n square plus phi n plus 6. Okay, this is an infinitely many series. N equal to 1, if you take, then you will have one term. N equal to 2, you will take, then it is another term. N equal to 3, third term. Infinitely many terms that you are having. And we would like to find out the uh, same method we would like to use. This kind of series are known as telescoping series. આગલા example નું અને આ પણ છે. So this is an. This is an. Okay. Can I say an is like this? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Can I write this as, check?
Yes, sir.
Okay, everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Now it is easy to find out Sn, because Sn is nothing but a1 plus a2 plus a3 and so on an. And so what is A1? One by two. No.
1/3 minus 1/4.
1 by 3 minus 1 by 4. A2.
1/4 minus 1/4.
1 by 4 minus 1 by 5. Isn't it? Same way, A3. 1 by 5 minus 1 by 6. And so on. An. 1 over n plus 2 minus 1 over n plus 3. And you can see that these terms will be getting cancelled. And it remains only like this. 1 by 3 minus 1 upon n plus 3. Agree?
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. That means you can easily find out limit n tends to infinity Sn. And that is limit n tends to infinity 1 by 3 minus 1 over n plus 3. And so this is 1 by 3 minus 0. Because when limit n tends to infinity, 1 upon n plus 3 also 0. Okay. So what you are getting now? 1 by 3. So sequence of partial sum is converges to L. And therefore, by definition, this infinite series. So you can see that you are having very infinitely many terms, but it has a exact sum, and so it is convergent also. So these are the examples, which is known as some telescoping series, and we can find out the definition root. Okay, fine. So this is the
Yes, sir.
yeah, one kind of series that you are having. Okay. Now, okay, so write down. Okay, done.
Yes, sir.
Okay,
Yes, sir.
okay. Next, let us see geometric series. Okay, for finite many term you studied in your 11th, 12th standard, but now we are having infinitely many terms. So geometric series is like this: A plus AR plus AR square, AR power n minus 1. You have studied up to this n terms, but now we are having infinitely many terms. Go on, continue. Okay, go on, continue. Infinitely many terms. AR power n, AR power n plus 1, AR power n plus 2, and so on. Okay, this is the geometric series. Now we would like to see if you remember, what is Sn? Sum of the n terms. So a plus ar square and so on, ar power n minus. You remember the formula here? You have in your 11th-12th standard. Do you remember formula for sum of the first n terms of geometric series, Sn?
A r raised to n minus 1 upon r.
Upon r नहीं, but upon r minus. Okay. Now see, even if you see the calculator, if you take any number, which is like this, its modulus is less than 1. કોઈ પણ એવો નંબર લો કે જેનો મોડ્યુલસ less than 1, like 0.2, અને પછી તમે 0.2 ના પાવર લો, so will it be increase or decrease?
Decrease.
A decrease time. Okay, that will be decreasing. So we know these things. That means if modulus r is less than 1, decrease થાય એનો મતલબ આવો થાય. In that sense, limit n tends to infinity, r power n is 0. You understand? If modulus r is less than 1, then you take its power. Take power લીધા જ કરો તમે. Suppose 0.1, so 0.1 no power 2, 0.1 power 3, 0.1 power 4, 0.1 power 5. You will see that it goes towards 0. So it decreases and it will be 0. Okay. So
Yes,
in
sir.
in this sense, what happened? Limit n tends to infinity, Sn is equal to limit n tends to infinity. I can write this way: a into 1 minus r power n upon 1 minus r. Same. If I write 1 minus r power n and 1 minus r, no problem. Now in this sense, in this where modulus r is less than 1, this r power n is 0. When you take limit n tends to infinity. So then you are having a upon 1 minus r. Understand? That means this is a finite number. A means the first term and 1 minus r is the ratio. Geometric sum series means the ratio. First term ને second term થી divide કરો એટલે r મળે. Third term ને second term થી divide કરો એટલે r. Second term ને first term થી divide કરો, you will get r. Third term ને second term થી divide કરો, you will get r. So r is the ratio, a is the first term. So what does it mean? It means that if modulus r is less than 1, then આને general લખાય આ રીતે, series n equal to 1 to infinity a r power n minus 1. Okay. So then this series is convergent and it has exact sum, which is a upon 1 minus r in this situation. You understand? Fine. And say if r is greater than 1, modulus r is greater than 1, then what happens? Then limit n tends to infinity, r power n શું થાય if modulus r greater than 1? Suppose
Infinity.
modulus r infinity થાય. Exactly. Suppose r 2 છે, 1.5 છે, તમે એના પાવર સીધા કરશો, so it will goes to infinity. એ કાં તો ઇન્ફિનિટી થાય કાં તો માઇનસ ઇન્ફિનિટી થાય, ડિપેન્ડિંગ ઓન આર પોઝિટિવ ઓર નેગેટિવ. પણ એ કાં તો ઇન્ફિનિટી થાય કાં તો પ્લસ માઇનસ ઇન્ફિનિટી થાય. ઓકે, that means in this situation limit n tends to infinity, Sn is either infinity or minus infinity. That means limit does not exist. That means if modulus r is greater than 1, then this series, geometric series, is divergent. It is not convergent. Now if suppose r equal to 1, r is 1, then what happen? A બધા terms a થશે. ખબર પડે છે? Yes or no?
Yes, sir.
Yes, sir.
Yeah, તો પણ Sn શું થાય? What is Sn? Sn is a plus a plus a plus a n times. And so it is n times a. And તો પછી limit n tends to infinity, Sn શું થાય? Infinity થાય. Yes or no? એવી જ રીતે
Yes, sir.
r minus 1 હશે તો પણ એ કઈ નહીં થાય. એટલે કે then it is like minus 1 છે. Like this. A minus a minus a minus a આવું થાય. પણ તો આ કન્વર્ઝન ના થાય. એવું ના થાય કે આ બે ની જોડી બનાવી દઈએ એટલે 0 0 0 અને બધાનો સમ 0. એવું નહીં થાય. ભાઈ એવું નહીં થાય? Because there are infinitely many terms. એટલા માટે એવું નહીં થાય. ઓકે, તો આમાં Sn ની બે વેલ્યુ મળે. Sn n ટર્મ્સ કાં તો 0 મળે વેલ્યુ અને કાં તો a મળે. યસ ઓર નો? તો Sn ની બે વેલ્યુ આવે
Yes, sir.
ત્યારે Sn કન્વર્જન્ટ ના થાય અને ઓસિલેટરી કહેવાય. લાઈક પેલું -1 2 -3 4 -5 6 એ રીતે. That is oscillator. એટલે Sn કાં તો 0 થાય કાં તો a થાય. So that is oscillatory. And any oscillatory sequence never converge. એટલે લિમિટ ના મળે ઓસિલેટરી હોય. Sn ની વેલ્યુ કાં તો 0 હોય કાં તો a હોય, કાં તો 0 હોય કાં તો a. So that is not exist. એનો મતલબ કે સિરીઝ એ ડાયવર્જન્ટ થાય. કયા કેસમાં? -1 હોય ત્યારે. r equal to 1 હોય ત્યારે પણ શું થાય? ડાયવર્જન્ટ થાય. મોડ્યુલસ r greater than 1 હોય ત્યારે પણ શું થાય? ડાયવર્જન્ટ થાય. મોડ્યુલસ r less than 1 હોય ત્યારે શું થાય? કન્વર્જન્ટ થાય. આનો બધાનો એકાઉન્ટ લઈએ તો શું થાય? Therefore series n equal to 1 to infinity a r power n minus 1 is convergent if and only if modulus r less than 1. અને અહીંયા સમ પણ મળે છે. એક્ઝેક્ટ સમ શું થશે? a upon 1 minus. બાકીના કોઈ પણમાં ડાયવર્જન્ટ થાય છે. This is the concept of geometric series. Do you want to write?
Yes, sir. The last line.
Okay. બેઝિકલી આ થિયરી કોઈ પૂછશે નહીં. Okay, basically this theory will not ask, but examples will ask. એટલે તમારા માટે આ જોઈએ છે. This is the part. Okay.
Yes, sir.
Yes, sir.
Okay. Let us see example. Check for convergence and find sum. જો find the sum હોય ને તો તમારી પાસે only two options. કાં તો telescoping series હોય એટલે convergent હોય છે, અને કાં તો geometric. એ સિવાય બીજી કોઈ પણ convergent માં sum મળશે નહીં. Convergent મળશે એટલે કે you will say that sum is possible, but exact sum we don't know. But if the sum is possible and exact sum is also, we are in a position to say, then those series are either telescoping or geometric. બાકીની બીજી કોઈ series માં exact sum નહીં. Convergent, divergent will be there. Okay. So telescoping, yes, we have seen two examples. Let us see geometric one or two examples. So the series is like this. Like this is a series. So first of all, we need to check this is a series. Is this a geometric series or not? Geometric series is a form A plus AR plus AR square and so on. એટલે કે second term divided by first term કરો, third term divided by second term કરો, એટલે તમને જો exact R મળે same, then it's a geometric series. So it is just there. You can see that it's a geometric series. Once it is geometric series, you should find out A. A is the first term. And then you need to find out ratio also, common ratio. What is common ratio here?
3/2.
Eh?
2/3.
2/3. Okay. So 1, 2/3. Multiply 2/3, you will get 4/9. Multiply 2/3. Okay. You will get like this. Okay. A. Then AR. Then AR square. Then AR cube and so on. So it's a geometric series. Now what about R? This is the concept. Does modulus R less than 1? Less than 1 or greater than 1?
Less than 1.
So less than 1.
Yeah. So that means this series is like this. Series n equal to 1 to infinity A R power n minus 1. So 2/3 power n minus 1. Okay. Geometric series is always like this. A R power n minus 1. Okay. A is 1 here. R is 2/3. So R is less than 1. Modulus R is less than 1. That means this series is convergent. And here we can find this sum also. What is the sum? A upon 1 minus R. So A is the first term and R is the ratio. So you can see that this is 3. Okay. So that means this series 1 plus 2/3 plus 4/9 plus 8/27 plus 16/81 and so on. Its exact sum is what? Infinity many terms. આ બધા infinity many terms. એક પછી એક term નો sum કરવા જાઓ તો આખું જીવન પૂરું થઈ જાય, સમ ના થાય. પણ અહીંયા તમે જો we can able to find out exact sum. That is okay. Write down this. Done?
Yes, sir.
Okay. Test the convergence and find sum. If convergent, then find the sum. 5, then minus 10 by 3 plus 20 by 9 minus 40 by 27 and so on. Okay. So, is this geometric series first of all?
Yes, sir.
Yes, sir.
Okay. What is A?
Right.
What is R?
Minus 2 by 3.
Minus 2 by 3. So, आने minus 2 by 3 से multiply करो, you will get this. आने minus 2 by 3 से multiply करो, you will get plus sign because minus sign already. Minus 2 by 3 से multiply करो, you will get like this. So, R is minus 2 by 3. What about modulus R? 2 by 3. Is it less than 1 or greater than 1?
So less than 1.
Less than 1. Okay, fine. This is
Sir,
the series
sir,
like
sir, 3 by 5.
A R power n minus 1. So series 5 minus 2 by 3 power n minus. This is a series that you are given. Yeah, modulus R is 2 by 3 and it is less than 1. Therefore, given geometric series is convergent because modulus R is less than 1. What is the sum? A upon 1 minus R. A is what? 5. 1 minus. What is R? Minus 2 by 3. So this is 5 upon 1 plus 2 by 3. And so it is 3. Yes or no? And therefore,
Yes, sir.
yeah, therefore, the series that you are having 5 minus 10 by 3 plus 20 by 9 minus 40 by 27 and so on, or you can say series 5 minus 2 by 3 power n minus 1 is having exact sum 3. Convergent and exact sum is 3. Agree, everyone?
Yes, sir.
Yes, sir.
Yeah. So you may write down this also. Written?
Yes, sir.
Okay. Test the convergence and find sum if convergent. The series is like this. 3 power n minus 1 minus 1 upon 6 power n minus. This is a series. Now see, this you can write as can I write in this way 1 by 2 power n minus 1 minus 1 by 6 power n minus 1? Yes or no?
Yes, sir.
Yes, sir.
Because this is 3 by 6, that is 1 by 2. So you are having two series like n equal to 1 to infinity 1 by 2 power n minus 1 minus there is n equal to 1 to infinity 1 by 6 power n minus 1. Both series are geometric series. But both are having different a and r. Means a is what here? N is 1, you take 1 minus 1, 0, 1 by 2 power 0, so this is 1. And what is r? 1 by 2. Here a 1, but r 1 by 6. In both case, modulus r is less than 1. Agree or no?
Yes, sir.
So that means this is also convergent. This is also convergent. And two convergent series you are having, and its subtraction is also convergent. If any one of them divergent, then the whole series is divergent. But if both the convergent, then sum, subtraction, it's always convergent. Even multiplication also. Okay? That means given series is convergent. Now we would like to find out the sum. What is the sum? Sum formula is what? A upon 1 minus r. So for this, the sum is what? 1 upon 1 minus 1 by 2. Then negative sign. Another sum is 1 upon 1 minus 1 by 6. Yes or no? So this
Yes,
is
sir.
2
Yes, sir.
minus 6 minus 1, 5, 6. So this is 6 by 5. And so it is 10 minus 6, so 4 by 5. So this series has the sum 4 by 5, given series. You understand?
Yes.
Yes, sir.
Yes, sir.
Yeah. So we stop here. Okay. And okay, everyone?
Yes.
Yes, sir.
Okay. Bye then.
Thank you,
Thank
sir.
you,
Thank you,
sir.
sir.
Thank you, sir.
Yeah.